Hi students. Today we are going to discuss about the osmotic pressure actually. So we will go detail about the osmotic pressure, the meaning of osmotic pressure, problems on osmotic pressure, usage of osmotic pressure, reverse osmosis. This all the things which we are going to study in this lecture today. We are discuss about the osmotic pressure. So here let us join now on the screen which I have to share here. This is the screen. Yeah, it taking a time, 1 minute. Yeah. So this is what the osmosis and osmotic pressure. See, student, osmosis is related to vapor pressure. Okay, one thing you should know, the osmosis is related to vapor pressure. Okay. Once you get to know the concept of vapor pressure, you can define the osmosis. So let's have a look over this point that what the osmosis. Here we are having the SPM student, SPM. And SPM is what is called a student that is semi-permeable membrane. Okay, here is SPM. This is what termed as semi-permeable membrane. Permeable membrane. This is the This is actually measure of the pig bladder or the some cellulose like things. Okay, or cellophane. So what is there, student? Suppose this is the one system is there. One side here is the solution. This is the solution. Okay, solution in the term that is what solute. What solute we are talking about? That is solid solute plus it is solvent. This is the things. If you are talking about this side, student, this is only the solvent. Okay. Now, if I will ask you where the pressure is going to be high, student. So pure solvent, liquid, pure solvent is liquid here we are talking about. That is the water. This side also. So if it is the pure student, all the pure solvent means that is all the particle, vapor pressure is the surface phenomena. So all the particle will going to be vaporized. So high vapor pressure. And solution, if you talk about this one, high vapor pressure. So to maintain the vapor pressure of the total solution, what is going to happen here? That is this solvent particle will move from where, student? Will move from the solvent to solution side. Okay, low concentration to high concentration. So, and SPM, this one is allow only, which one? Allow only solvent particle to move. Solvent to move. This is, you have to keep in mind, only solvent to move. So this is going to move this side. Why? To equal the vapor pressure. This is represented by P naught and this is represented by PS or only P. Now, this osmosis phenomena will continue, go on, keep on going. Now, another concept arises here. How to stop this osmotic phenomena? What you need to do? So, if you apply the pressure this side, so that this is going to stop, student. This is so this pressure, whatever the pressure you apply, represented by pi, that is called osmotic pressure. So here they are saying pressure applied. Where you are here, we are writing the definition: osmotic pressure. Osmotic pressure. So what is this, student? If what is this? Pressure. Pressure applied. Which side you are going to apply, student? Pressure applied on solution side. This is solution side. To stop the flow of solvent. To stop osmotic pressure. Now, student, that is the osmotic pressure is again going to be colligative properties and depending on molarity. So if I will write pi means osmotic pressure proportional to what is molarity. So pi is equal to, if you are writing this molarity, pi proportional to capital M is there. So pi is equal to, we are writing the constant C, the R and T, because this molarity is temperature dependent. This is what factor is temperature dependent, that we have to understand. Dependent, molarity is temperature dependent. And if you are talking about molality, temperature independent. This is the temperature independent. Okay. Now, if you are dividing, this is the concentration. What is this one? C is the concentration. So concentration, you can write N2 by V. Okay, N2. What is the N2? N2 means number of moles of solute. Number of moles of solute. Moles of solute. And here, if I will go V, volume of solution in liter. Volume of, this is going to be solution in liter. Now, let us define pi is equal to N2 by V RT. This is the liter that you need to keep in mind. What is the N2, student? Given mass over, we can write what? Molar mass. So here is pi is equal to, we can write here, given mass over molar mass multiply by R into T divided by what is going to be there, student. Here, if you see, so that is V liter. That is V liter. So now molar mass, if you are calculating molar mass, so given mass multiply by R multiply by T, here is going to be pi into V liter. Okay. If suppose this is given in the ml, so what we will be the formula? Molar mass generally we calculate by the osmotic pressure. So it will be Gm R into T multiplied by 1000 divided by pi into, this is VmL. This is there. This is the second one. Right, student? If the solution is isotonic solution, let's try to know isotonic solution. Isotonic solution. So if I will ask you what is isotonic solution, student, iso means same, student. Tonic means that is going to be same concentration or the pressure. So, two solution here we are telling two solution having same osmotic pressure, same osmotic pressure is called isotonic solution. Two solution having same osmotic pressure is called isotonic solution. Means if I will go pi 1 for first one, it is going to be equal to pi 2. Pi 1 is CRT is equal to, again CRT, here is it is going to be C1 and C2. Now RT will be cancelled out. C1 and C2, this is going to be N1 equal to, this is going to be N2. Or you can write that is W2 upon M2 equal to W1 upon M1 is going to be equal to W2 upon M2. With this formula, we can calculate the molar mass of the any substance. Now, let's try to have a look over it, what the NCERT is saying. So, osmosis. There are many phenomena which we observe in nature or at home. For example, raw mangoes shrivel. When pickled in brine, salt water. Okay. Wilted flower revive when placed in fresh water. So if wilted flowers is there, this is going to be rejuvenate. Blood cell collapse when suspended in the saline water. Okay, etc. If we look into these processes, we find one thing common in all, that is all these substances are bound by membrane. What is? That is, the bound by membrane is what is called semi-permeable membrane. So they are saying whether you are placing the, okay, wilted flower, okay, if you are putting in the water, it will rejuvenate, it will glow. Okay, if you are putting the blood cells in the saline water, it will collapse. These things phenomena we know. But what is the common in this one? That is what the common thing is there. Membrane is there. Okay. This membrane can be of what animal, vegetable origin, and these occur naturally, such as pig bladder. Which one you are using, student? Pig bladder. Okay. That you need to keep in mind. Okay. Another things or parchment. This is parchment paper can be also used, student. Secondly, or can be synthetic such as cellophane. So chemically you are taking cellophane. These membrane appear to be continuous sheet or film, yet they contain a network of microscopic pores. So what the SPM is there? They contain what? Microscopic pores, student. Okay. Now, a small solvent molecule like water can pass. Which one, student? Solvent molecule, not solute. Can pass through these holes, but the passage of bigger molecule like solute is hindered. Solute is not allowed. Only solvent can be passed. Membrane having this kind of properties is known as semi-permeable membrane. This is the SPM. Now, what is the SPM? The semi-permeable membrane which allowed only solvent particle to move. That is what SPM. Now, see the here diagram. What is there, student? This is the semi-permeable membrane. If you find this one, okay, containing what it is containing, student. This one, whatever the slide you are seeing this one, this contains solution. It is having low vapor pressure, and this is the pure solvent here. So what will happen, student? Flow of this will pure solvent go inside, and it will generate it will go up. Okay. So H rho G. Okay. This pressure, they are going to exert to stop the flow. If you are talking about to stop the flow, okay, of this whatever inning water, that is what is called osmotic pressure. Let us have a look about the slides here. They are saying, assume that only solvent molecule can pass through this semi-permeable membrane. If membrane is placed between the solvent and solution, as shown in figure 2.9, the solvent molecule will flow through the membrane from pure solvent to the solution. This process of the solvent is called osmosis. So that point you need to know, student. So one thing here they mention, student, the process of flow of the solvent is called osmosis, where the solvent molecule will flow through the semi-permeable membrane from pure solvent to solution. This is called osmosis. Now, let us see the another point here. The flow will continue till the equilibrium is attained. That keep in mind, the flow of the solvent from its side to solution side across the semi-permeable membrane can be stopped if some extra pressure is applied on the solution. This flow can be stopped, student, if you are applied what? Extra pressure to the solution side. This pressure that just stop the flow of solvent is called osmotic pressure. So you should know what is osmotic pressure. The pressure which you are applied to stop the flow of solvent. To stop the flow of solvent is called what, student? That is osmotic pressure. The flow of solvent from dilute solution to concentrated solution across the semi-permeable membrane is due to osmosis. Okay. The flow of solvent from dilute solution to concentrated solution across semi-permeable membrane is osmosis. The important point kept in mind that the solvent molecule always flow from the lower concentration to higher concentration of solution. Lower concentration to higher concentration of solution. The osmotic pressure has been found to depend on the concentration of solution. Which concentration term, student? Molarity. So here you see, if you can see here, this is this one, the pressure is there, already pressure is there. Okay. Here you are applying extra pressure so that the flow can stop, student. That is what is called the isotonic solution, right? So, hello, hello.
Yes, sir, I'm sorry I'm late. Sir, can you please excuse the class?
Okay, no problem. Okay.
Actually, we have today our 11th results came out, so I don't know how much they got, but they gave me still physics in here about 48. I said that previously that I did not call you, sir. Overall, my father told me not to touch any book and copy paste again.
No problem. So today result came, your result came.
Yes.
So that is not good. Result is not good, no?
To connect.
Chemistry, how many marks you got in chemistry?
I don't know the exact sir. They're saying I asked my sir. He's saying in physics or chemistry, they're about 48, around 48 that way. I bonus one.
Okay. No problem. Hmm. So here you see, students, the osmotic pressure of solution is the excess pressure that must be applied to solution to prevent osmosis. This point, every time the osmotic pressure is being defined in the many ways, student, that you need to know. That is, here the pure solvent is there, this side. Actually, this is the bigger figure. This is the solvent and this is solution. So particle is obviously going to move this way. This is the SPM already mentioned. So we have to stop. And whatever the extra pressure we are supposed to apply, that is osmotic pressure, to stop the passage of solvent molecule through the semi-permeable membrane into solution. This is illustrated in figure 2.10. Okay. Now, osmotic pressure is colligative properties as it depends on the number of solute molecule and not on their identity. See, student, osmotic pressure is colligative properties that depend on the number of solute molecule and not on their identity. For dilute solution, it has been found experimentally that osmotic pressure is proportional to molarity. What is the student? Osmotic pressure. See, ELVP, elevation in boiling point, student. Elevation, ELVP. It is depending on smaller molality. Relative lowering vapor pressure, RLVP, relative lowering vapor pressure. This is the X to mole fraction. Depression in freezing point, DFP, it is molality. And if I osmotic pressure, that is molarity. So here two are the same. Here you see they are depending on the molality, but here relative lowering vapor pressure, mole fraction absolute, and osmotic pressure is molarity. So here they are saying osmotic pressure is proportional to molarity. C of the solution is given at temperature T. Thus, pi is equal to CRT. Okay, this is point. Here to the osmotic pressure must be applied on the solution side to prevent osmosis. Pi is equal to N2 by V. This is going to be RT. Pi is equal to N2 by V RT. This is why we are writing N2 by V. C is the concentration term. So number of moles of solute, that is N2 by volume of solution in the liter. RT, this is the proportional constant called gas constant. T is the temperature. Here now you can define here. Here V is the volume of solution in liter containing N2 mole of solute. If W2 gram of solute of molar mass M2 is present in solution, then N2 is equal to W2 by M2, given mass by molar mass. You can simplify this formula in this term. M2 is equal to WRT by pi p. This is very simple. If you knowing the quantities, these all the we can calculate the molar mass of the solute. Okay. Measurement of osmotic pressure provide another method of determining the molar mass of solute. Okay. There are the more to get the molar mass of the solute. There are the relative lowering vapor pressure, depression in freezing point, elevation in boiling point. One more property is there, that is osmotic pressure you can use. This method is widely used to determine the molar mass of protein. Okay, macromolecule, polymers, and other macromolecule. That is macromolecule, bigger molecule. The osmotic pressure method had the advantage over the other method as pressure measurement is around the room temperature and the molarity of the solution is used instead of molality. So if the room temperature is there, you can use what student osmotic pressure. They are saying it is an advantage. It has the some advantage. What is The osmotic pressure method has the advantage over the other method as pressure measurement is around the room temperature and the molarity of the solution is used instead of molality. As compared to other colligative properties, its magnitude is very large. Its magnitude is very large, even very dilute solution. The technique of osmotic pressure for determination of molar mass of solute is particularly useful for biomolecule as they generally not stable at higher temperature and polymers have poor solubility. So this is there. Now let us see the some other point what are there. The solution having same osmotic pressure at given temperature is called isotonic solution. If somebody is asking what is isotonic solution, student, that is two solutions having same osmotic pressure at given temperature is going to be the isotonic solution. When such solutions are separated by semi-permeable membrane, no osmosis occur. No osmosis occur between them. No osmosis occur between them. When such solutions are separated by semi-permeable membrane, no osmosis occur between them. For example, the osmotic pressure associated with the fluid inside the blood cell is equivalent to the 0.9% by mass by volume sodium chloride solution called normal saline solution. Okay. So how much, student? Normal osmotic pressure associated with the fluid inside the blood cell equivalent to 9.9% by mass of sodium chloride solution is called normal solution. And it is safe to inject the intravenously. Okay. Now see the another point. On the other hand, if we place the cell in a solution containing more than 0.9 percent mass by volume sodium chloride, water will flow out of the cell. They would shrink. Such solution is called hypertonic solution. Hypertonic means more concentrated, more concentrated. Now let, if the salt concentration is less than 0.9 mass by volume, the solution is said to be hypotonic, less concentrated. So iso means same concentration. Okay. How much same concentration? 0.9% mass by volume. Okay. If it is more than 0.9% M by V, that is called hyper. This is the HYPER. Hyper. Higher concentration. Less than 0.9. Okay. So that is what is mass by volume. That is what they are saying, hypotonic solution. In this case, water will flow in the cell, it place this solution and they would swell. Okay. Now let us see the another one. The phenomena mentioned in the beginning of this section can be explained on the basis of osmosis. Okay. A raw mango placed in concentrated salt solution loses water by osmosis and shrivel into pickle. The pickle process is like that. Okay, which solution you are putting the mango for the pickle? That is too much salt you are using, na? So that is the hypertonic solution. Next one, wilted flower review. When placed in fresh water, a carrot that has become limp because of water loss into temperature into the temperature can be placed into water, making it film once again. Okay, why? Because you are placing in which one? Hypotonic solution. So osmosis will take place. Water will move into them through the osmosis. When placed in water containing less than 0.9% mass by volume salt, blood cells swell due to flow of water in them by osmosis. People taking a lot of salt or the salty food experience water retention in tissue cell and intracellular space because of osmosis. The resulting puffiness or swelling is called edema. This is the puffiness called edema. Water movement from soil into plant root, subsequently into upper portion of the plant is partially due to osmosis. The preservation of meat by salting and fruit by adding sugar protects against the bacterial action through the process of osmosis. A bacterium on the salted meat or the candied fruit lost water, shrivel, and died. So this is there. See the question, student. Here question is there. Two 100 centimeter cube of aqueous solution of protein contain 1.26 gram of protein. So W2 they have given 1.26 gram, and volume of solution they have given V2 200 centimeter cube, that is ml. The osmotic pressure of such solution, temperature they have given 300 Kelvin, is found to be this one bar. Pi is equal to the 2.57 into 10 power minus 3 bar. Calculate the molar mass of protein. So that is already we have done. Pi equal to CRT. This we know. Pi is equal to N2 by V RT. Or you can write here what is, that is pi is equal to W2 upon M2, here is V, this is into RT. So M2 you are writing, so W2 into R into T divided by pi into V. V it is ml. So V ml is there, so you need to divide by 1000. So 1000 will go in the numerator. So W2 they have given student how much? 1.26. Here is bar. In case of bar, we have to take the pressure in bar, student. So pressure in bar, that is, it will be the one bar, student. Temperature here is the temperature is 300, and here is the 1000 already there. Here pi already there, student. 2.57 multiplied by 10 power minus 3, and here is the volume is they have given 200, right? So uh, let us go with the calculation, student. I am using the calculators to find out the answers. So R value little bit change, student. 0.083 liter bar. Here R value is little bit we have to change. Okay. How much is there, student? 0.08. This is there. Remaining things are as it is, student. Now, if you are calculating this one, so what will happen? These three will go in the numerator. Okay. So here 1.26 into 0.08. 0.083 into 300 multiplied by here 1000, and here this will go in the numerator, so it becomes the 1000 again, divided by, it is going to be what? 2.57 multiplied by 200. This 200 will going to be cancelled up by 5 times. Now with this 30, this decimal will be cancelled. Okay. So here is 126 multiply by 83 multiply by 300 divided by 257. Decimal, this decimal and this decimal got cancel out. Now if you are solving this one, how much is coming, student? 61022, 61 gram per ml. This is the 61,022. This is the gram per ml. You can use the calculator to get the answer. Okay, very easily you can calculate 126 multiplied by 83 multiplied by 300. So it is coming how much? 3,137,400 divided by how much? 257. So if you have been dividing this one, student, I am getting exactly the same answer, 257. So this is coming the same answer. So this is all about the answer, student. Now let us move out the next question. This question already they have done. You can check it. Here, this is the one more question are there, student. This is the same question. No need to do this one again and again. Here, this question we are going to do. A 4% solution of sucrose is isotonic with 3% solution of unknown organic substance. Calculate the molar masses of unknown substance. So here, student, this is the isotonic solution. So pi 1 is equal to, this is pi 1 means sucrose. So sucrose is S and unknown means U. So pi S is equal to pi U. So here is CSRT is equal to CURT, unknown solution. RT, same temperature going to be cancel out. So it is W2 upon M2, W2 upon M2. Here is going to be W1 upon M1. So this is, the first one is going to be for sucrose and this is going for the unknown solution. Here they are giving how much, student? W2 is equal to 4 gram. 4% means 4 gram. Sucrose molar mass M2 how much, student? 342 gram per mole. And W1 is given 3%. 3% means what much, student? 3 gram. And M2 they are asking how much is going to be. So what we can do here, we can plug the value here. W2 4, M2 means 342 divided by here W1, no? W1. W1 is 3 divided by M1 they are asking. So M1, what will be there? M1 is equal to 3 into 342 divided by 4. Okay. So here you see 3 into 342 divided by 4. So 256 is coming, student. 256.5 gram per mole. So this is the going to be M1. So molar mass of a known solution is substance is how much? 256.5. You can verify the answers here. It is there in the slide. So answer is absolutely 256.5 gram per mole. Now let us try to solve some more problem, students. What is there? This solution is there. Okay. So 100 gram of protein, this is there, 100 gram of protein dissolved in just enough water to make the 10 ml of solution. If the solution has osmotic pressure 13.3 mmHg, has 25 degrees C, what is molar mass of protein? So R value they have given 0.0821 liter atm Kelvin per mole and 760 mmHg. So this is there, students. So how can we solve this question, student? So this is again going to be very simple because here pi value they have given mmHg. This is there. So let's try to solve it out, student. So pi is equal to 13.3. This is the mmHg. Okay. If you want to calculate in the ATM, okay, in ATM, suppose if I am going in ATM, because this value is given in the ATM, 760 mmHg is equal to 1 ATM. So what we will there, student? 1 ATM, this is the 1 ATM upon 760 mmHg multiply by 13.3 mmHg. So this mmHg cancel out. So 13.3 upon 760, this is the ATM. So what will be there? 0.0175. This is the ATM. Okay. Now, because this value are there na ATM, R value. So we need to calculate mmHg into ATM. Now we can apply the formula. Pi is equal to W2 upon M2 RT upon V. This is there, student. So temperature is how much they have given? 25 degrees C, but we have to take Kelvin because this unit is in the Kelvin. 25 plus 273, that is going to be 298 Kelvin. This is the 298 Kelvin. This is there. Now, here volume you can find out here. 100 gram is there. That is okay. Dissolve in just enough water to make the solution how much? 10 ml. Enough water to make solution, to make 10 ml solution. This is there. So let's try to write down this value. So we need it in this one. You see what is they are asking. What is the molar mass of protein? So you modified this formula. M2 is equal to W2 into R into T by pi into P. W2 already they were given student. How much is there? That is the 100 gram, you can see 100 milligram. 100 milligram means what? In the gram we have to take a student. So 0.1 gram. This is going to be 0.1 gram. Multiply by R value 0.0821. Multiply by temperature already we have calculated 298. Okay, pi value they have given student 0.0175 atm that we just calculated. And that is the volume. Volume is 10 ml. 10 ml means you have to divide by 1000. So it is going to be 0.01. So it is 0.01. If you solve this one, it is coming 13980.457 gram per mole. So there are many problems are there in this slide I have taken, student. This I am not going to discuss all the point here. Yeah. Like this one question you see, isotonic with the 0.87 solution of urea. Okay, this is asked in the previous year exam also. If you want to solve, we can do very simply. This is not very tough question actually. Yeah, it's got hang up, hang up. Huh. Let me do this problem actually, this one. We got this, we got hang out student a little bit. Hmm. This stylus is not moving at all here and there. Should be visible now. Mhm. Okay, see a 5% solution of cane sugar. So if you are writing this one, pi 1 is equal to going to be pi 2. Isotonic means this is the urea. This is what is urea. So cane sugar, this is the sugar and this is the urea. Okay. So pi 2 is going to be for the urea student. We are talking about pi 2 that is going to be for the urea. This you need to know. So if you are dividing, this is the CRT equal to CRT. This RT will be cancelled out. So W2 upon M2 is equal to W1 upon M1. So W2 they have given 5% means 5 gram. M2 cane sugar 342. Okay. W1 they have given 0. How much? 0.877 gram. Divided by M1 they are asking solution of urea. Calculate the molar mass of urea. Very simple. So M1 is equal to what is 342 multiplied by 0.877 divided by 5. If you solve this one, dear students, if you solve this one, let me check the answer, how much is coming. It's coming. Wait. Answer is already given, student. Here 60 they have given. So we can divide it out. To divide it, we have to use the calculator here actually, because they are the decimal numbers are there. So 342 multiplied by 0.877 divided by 5. So 59 it is coming actually. 59.98 gram per mole. So round figure it is going to be 60 gram per mole. So molar mass of urea is, this is the confirm now. Okay. Now what we have to do, student, we have to understand the reverse osmosis also. There are many questions those who require the this slides. I will share you. This previous year questions are also mentioned in that you can go. Let me take reverse osmosis, concept of reverse osmosis. It's not appearing here. So let me take the slide actually. Yeah. So we need to know that is reverse osmosis. Reverse osmosis in the This year, this is question in the question paper, it came as student 2024. Reverse osmosis. It's a quite important one. Reverse osmosis is obviously important one because all the phenomena, aquaguard and all the purification of water based on the reverse osmosis student. Okay. And reverse osmosis, you need to know that is it is the extra pressure student. What pressure? That is going to be extra pressure. Where you are going to apply near the solution side. So reverse osmosis here you see student, this is the reverse osmosis and water purification. The direction of osmosis can be reversed if the pressure larger than the osmotic pressure is applied to the solution side where you are applying solution side. This is salt water, this is the solution. This is the pressure whatever applied above the osmotic pressure. So the here is solvent molecule from the solution going to be out. Solute cannot pass and this water is outlet. So here you see that is now the pure solvent flow out. Pure solvent what is going to be flow out from the solution. This is the pure solvent going to be flow out from the solution student. Okay. Through the semi-permeable membrane. This is the semi-permeable membrane. This phenomena is called what student? Reverse osmosis and is of great practical utility and is great practical utility. Reverse osmosis is used in desalination of the seawater. That is, you can remove the salt from the seawater. Systematic setup for the pressure is shown. Okay, process is shown. When pressure more than osmotic pressure is applied, pure water is squeezed out of the seawater through the semi-permeable membrane. A variety of polymer membrane are available for this purpose. So this is the isotonic osmotic pressure already there. More than the osmotic pressure is to stop the flow from this side to this side. But you are putting more pressure so that water is going to this side, the fresh water. Now let us see this one. The pressure required for the reverse osmosis is quite high. A workable pressure, porous membrane is film of cellulose acetate placed over the suitable support. Cellulose acetate is the permeable to water, but impermeable to impurities and ions present in the seawater. These days, many countries use the desalination of plant to meet their potable water requirement. Okay, so this is their concept. Now, in the next class, we will study the abnormal molar mass student. Thank you very much.